In this lesson here, we're going to be taking a look at volume of basic 3D objects. Now, up until this point, we've been looking at surface area, and that's all the stuff that is surrounding, and it's all kind of that flat or the pieces that we can maybe, let's say, paint, if we were to consider that as an option. Volume is what is on the inside, okay? So, or how much it could store, or something along those lines. Okay? What is the inside amount of volume? Now, to find we're going to be looking at finding the volume of a prism, okay? And so that's what we're going to be looking at first, and then we're going to look at some other shapes later on. But we need to understand that volume is all about what we can hold. It's that inside stuff. Okay. Now, if we think of, just going back to this here, if we think of length, length is just a straight line. Okay, it's a straight line. It's how long is something. It's one dimensional. Area is two-dimensional. It's something that's flat, okay? So it has a length and a width to it. It's got two dimensions to it. Volume is three-dimensional, which means that it has three different dimensions to it. Everything that we see in our world right now is three-dimensional. Okay? It's all three-dimensional. It has some sort of volume to it. Okay? That's why we call it 3D. It's three-dimensional. Length, width, height could be something that we could consider that. Now, we're going to look at the volume of basic 3D objects. And when I say basic 3D objects, we're talking prisms. Okay? We're just going to go prisms right from there. A prism, okay, is any shape that has a set base. Okay, so in this case here, this is a triangular base. It's got a set base, and that base continues throughout the shape. Okay. Now we have a couple special cases, and we'll get to those in a little bit, but a prism has some sort of base, and usually that will not be a rectangle, except in one special case. It usually not be a rectangle. On your formula page, it's the surface and volume formula page. If we go down to these two right here, we have two special case prisms that I want to look at. The first one is a cylinder. Now, a cylinder is a round object which has a circle on top and on the bottom, which is exactly the same. Okay? And it's going to be continuous throughout. To find the volume, we can use this nice little formula here. Volume is equal to pi times radius squared times height. So if we know the radius and we know the height of a cylinder, we can find the volume. Okay? So that is our cylinder formula. The other one is our volume formula for a rectangular prism. A rectangular prism is the only prism that has all rectangles. Outside of that, they all have at least some other piece. Okay, so this one is a circle. A rectangular prism is all rectangles. Okay, a cube or anything that's square related, we could think of that as a rectangular prism as well. The volume is the length times width times height. So we're going to have three dimensions: length, width, and height that we need, and we're going to multiply those three together, and that gives us the volume. Okay? Find the three dimensions. Sometimes they'll be similar or the same, but often they'll be different. Okay, they may all be different. If anything is the same, it's a square-based prism, but that's totally fine as well. So we multiply the three of them together, and that gives us our volume. Any other shape, I'm going to go back here. Any other shape, I'm going to do regular prism, has this generic formula. We're going to look at this generic formula in our lesson here. So that generic formula, I'm going to put it up here. Okay, volume is equal to the base area times the length or height of our shape. Okay, so we can think of it as the length or the height of our shape. If it's on its side, it could be the length. If it's standing upright, it'd be the height. I'll call it the length in this case here. So it's the base area times the length. In this shape right here, we have a triangular prism. Okay, a triangular prism has a base of a triangle. So I'm just going to draw in our base a little bit here. This is the base. I'm going to shade in a little bit with green. Not because it's envious at all. There we go. Okay, so there's our base shape. It's our triangle. It's our non-rectangular side. So what we need to do is we need to find the area of the triangle and multiply it by the length of the object. Okay, a triangle. So again, we're going to be using some area formulas here, and just for our 2D shapes. Area is equal to base times height divided by 2. That's for a triangle. So what that means, so this is our base area. We can plug it back in here. And so our formula that we're going to use is going to be area is equal to base times height divided by 2 times length. Okay, and that's an L there, times length. So this is how we're going to find it. We're going to plug in whatever formula we need for our base shape. In this case, it's a triangle. We plug in there. We multiply it by the length. So let's do the calculations here. The area is equal to, well, the base is 10 millimeters of our triangle. The height is 12 millimeters. We're going to divide that by 2. I'm just going to get these brackets in the right spot here. Okay, and then we're going to multiply it, and I'm just going to put this in brackets, by the length. Now the length of our object is this side right here. Okay, it's a 14 millimeters. There we go. Okay, so now we have our base times height divided by 2. That gives us our triangle. Then we multiply that triangle by the length, and that's going to give us our area. So to do that calculation, I'm going to use a calculator here on the computer so you can see how I'm going to do a calculation. We're going to have 10 times 12 divided by 2. And I'm going to hit equals to get what's inside the brackets done. And I'm going to multiply it by the length. And so this is 840. Here. So our area, sorry, this should be volume. I apologize. All these letters should be V. I used area, or sorry, the first one should be A, but they should all be V for volume. I mixed it up using volume. Okay, that's area. This is area of a triangle. Now we're dealing with volume. Okay, the volume is equal to 840 millimeters cubed. Now, it's very important again with our units that we are cubing our units. There are 3 millimeters in here, so 1, 2, 3 millimeters cubed. It is a volume measurement. It's no longer an area measurement, it's a volume measurement. So that's why we do the cubed. Let's take a look at another example here. In this case, here we have a hexagonal prism. Hexagon because that is the non-rectangular shape on this prism, and it's a prism because it's got a hexagon there at the end as well. If it had a point, it'd be a pyramid, but it's both the front and the back are hexagons, so we're going to have a hexagonal prism. Now, to find this, we need to know the area formula for our hexagon. So our area is equal to the base times the apothem times the number of sides divided by 2. So there's our area formula, okay, and we're going to use that as our area formula. Now, 6 sides in a hexagon, so that'll be the n. So area, sorry, now we're going to go volume. Volume is equal to, I'm going to put this into brackets here, the base, 8.1 meters, times the apothem, 7 meters, times the number of sides, which is 6. And then we're going to divide that all by 2. And we're going to multiply this by the length of our prism, which now is that bottom piece. Okay, so the length of one of those rectangles, that's going to be our length. Okay, so 21 meters. Again, you'll notice here that we've taken our area formula and we've just plugged it right into our volume formula. Remember, volume is base area times length. This is the base area, so we plug it in there and we multiply it by the length. And our volume is, let's see if I can get all these numbers here, 8.1 times 7 times 6 divided by 2, and we're going to multiply that all by 21, and 3,572.1. 3,500 and, forgot that again, 72. 72.1, that's our number. Our units are meters cubed. Okay, so meters cubed is our value. So that would give us our volume. Now again, very important we use our units, okay, meters cubed. It's not just meters, that would be a length. This is meters cubed. It represents how many boxes that are 1 meter by 1 meter is the volume to it. Okay, so that is important to remember. Your assignment is questions 1 through 5. Make sure you are showing your work. Which formulas are you using? If it's a cylinder or a rectangular prism, you can just use the generic formulas that are given, which are actually based on this here. If it is something different, then make sure you're using our base area times length formula to find volume.